Hello and thank you for watching my video. My name is Astrid Krasniqi. I'm CCNA and CCMP certified instructor. On this video, we are covering new topics added to the CCNA course 200-125. And this is the last section, 4.13 Troubleshooting Scenarios. Upon completion of this section, you should be able to use an ICMP echo based IPSLA to troubleshoot network connectivity issues. IPSLA, or Service Level Agreement, are features of the Cisco IOS that allows the analysis of IP service levels. The IPSLA uses active traffic monitoring, generation of traffic in continuous, reliable and predictable manner for measuring network performance. A Cisco IOS IPSLA actively sends assimilated data across the network to measure performance between multiple network locations or across multiple network paths. The idea with IPSLA is that, for example, imagine that this is your company and the R1 is in there. Now R1, like we are medium-sized companies and we are connected to two ISPs. We're connected to ISP1 and ISP2. We can use both, so we can use it as a load balancing, or maybe we want to use ISP1 as a primary link and ISP2 as a backup link. The thing is that if this link between R1 and R2 fails, R1 automatically will switch to the backup path. But the problem is that what happens if it's inside the ISP, there's a problem. This link here between R1 and R2 is fine, but inside the ISP is not working at all. We want us to find out that if there's a problem inside the ISP for us to switch automatically to R3. So that's the idea. With IPSLA, you can, for example, test or measure the traffic, what's happening inside ISP1. For example, we can send ICMP echo messages to some DNS inside the cloud there to make sure that it's working. Everything is inside there is working. This link, we want to check that inside, not just link here, that it's functional. So the information collected includes data about response time, one-way latency, jitter, packet loss, voice quality scoring, network resources availability, application performance, and server response time. In its simplest form, a Cisco IOS IP SLAs verify whether a network element, such as an IP address on a router interface or an open TCP port on IP host, is active and responsive. So again, let's assume that R1 has a multi-home connection to the internet through ISP1 and ISP2. Two equal cost default static route on R1 enable the Cisco IOS to load balance over the two links on a peer destination basis. R1 can detect if there is a direct failure on the link to the one ISP, and in that case uses the other ISP for all traffic. So if there's a direct failure, R1 will detect that and it will say, okay, well, I can't use that, I'll use the other side. But the problem is that if there's indirect failure. So however, what would happen if a link within the ISP1 provider infrastructure were to fail? The link from R1 to R2 will still remain up, and router 1 would continue to use the link because the static default route will still be valid. How can this situation be corrected? Well, we can use the dynamic routing between router 1 and ISP network, but this is not practical. Another solution is to use either a static route or policy-based routing on router 1, but make them subject to reachability tests towards the critical destination, such as DNS server within the ISP. If the DNS server is one of the ISPs is to go down or unreachable, the static route towards the ISP would be removed. These reachability tests can be performed within Cisco IOS IP SLA. IP SLA can be configured on router 1 to probe the DNS server frequently. The IP SLA probes are attached to the static routes. So step to configure IP SLA is to first we define one or more IP SLA operations or probes, then define one or more tracking objects to track the state of IOS IP SLA operation, and step 3 is to define the action associated while tracking the objects. What I have here is a network that we're going to configure. This is router 4 connected. Imagine router 2 is ISP1, so ISP, for example, 1. And router 3, imagine that it's ISP2, right? So here, for example, is ISP2. Let's write it in capitals. So ISP2. Now, I have a PCC is connected to router 2 and PCA is connected to router 3. And imagine that that is our DNS, for example. So router 4 is going to be using ISP1 as a primary link. If the primary link fails, then it will use a backup link towards router 3. So we're going to create a static route that says, okay, well, we're going to be using ISP1 and we're going to be using ISP2. But ISP1 is going to be primary link and it's going to be subject to reachability to this PC. If we can ping this PC, we will use this as a primary link. That second that we can't ping and we'll disable it, we can look like the DNS is not working, we will switch towards router 3. Okay, so I have already a connection to all my routers. So if I say show session, you see I got router 1, not in this topology. We need router 2, 3, 4. And I've got connection to PCC and PCA. So if I go to PCA has shut down my virtual machine, and that's my PCC. So if I go to PCC and I do IP config, you can see the IP address is 10.1.1.2.200. So same as this, 10.1.2.200. And PCA, if I look at the IP address of this, I'll just change this address. So I'll do IP config 10.1.3.200. Okay, so 10.1.3.200, that's PCA. Cool. So I don't have any configuration on any of the routers, so it's brand new. I erased it and started, reloaded all my routers and router 3 as well. So only 2, 3, and 4, and router 4. Okay. The default startup configuration, that's the default startup, so I'll save you from actually seeing me writing these down. So I'm just gonna highlight it and copy, put it on router 2 first. So just right click and it's copied all fine, there's no errors. Just change the host name to R3 here and highlight it, copy it, put it in router 3 and router 4. So highlight, copy, Control Shift 6 X to go to my access server, press 4 to access router 4, and then paste. Cool. Now the rest of the configuration we're gonna need to do, so I'll complete it here. So this is say we start with router 4 here, R4. We're gonna say interface FA00 IP address 10.1.24.4 and /24. Description R4 to R2, and then no shutdown. Sorry, no shutdown. Okay, so I'll just highlight all that, copy, paste it here, and change this to FA01 and 34.3. This 34 should be 34.4 here. 34.4. So 34.4, and this is router 4 towards router 3. No shutdown. Okay, very good. So I highlighted, copy, and down here I'm gonna put it for, this is for my router 2 or 2. Interface in R2 is G01, so G04/1 and 10.1.24.2 here, and this is router 2 to router 4. No shutdown. And then G00 interface, it's got the IP address there, you can see G00 10.1.2.2 10.1.2.2, and this is router 2 LAN. Okay, then I'll just highlight, copy this, and I'll put it here for router 3. So this is router 3, interface G01 10.1.34.3, and this is router 3 to router 4. G00 10.1.3.3, and this is router 3 LAN. Okay, that's all configuration done. So if I highlight this and I'm going to paste it on my router 4. So copy, and then go to router 4, paste it there. Okay, it doesn't seem any errors, so that's good. Router 2, copy, go to my router 2, Control Shift 6 X2, and paste it there. Okay, it doesn't seem any errors there either, so that's good. And then router 3, copy, go to router 3, Control Shift 6 R number 3, and that's it. Paste it there. Everything is cool. Now I need to make, for example, a static route that says for router 4, for any network, because that's like a default route. For any network, go to router 2 and router 3. But router 3 is going to be my backup. The router 2 is going to be the primary link. Okay, so say this is for router 4, and IP route, all zeros, 0, 0, 0, 0. Any networks for any with any mask, I'm gonna just send it to my neighbor 10. So next hop IP address, which is the neighbor router 2 or ISP1. Then I do the same configuration, right? But this is the backup. So any network with any mask, and I'm going to send it to my neighbor 34.3. Okay. And then to make this as a floating static route, I just need to increase the static, so 200, for example. Okay. First, before I'm going to do this, I'm just going to do one by one, then delete it. Just make sure that I can talk to my PC. So copy this, and I'm going to check paste on router 4 and make sure that I can ping PCC. Then I'll remove that. Then I'll paste the other one to check that I can ping PCA, and then we do IPSLA. Okay. So I go to router 4 and exit here, and all I can do is paste it. Any network with any destination, I'll send it to router 2. Enter. Now end, and I'll see if I can ping that PC. So ping PCC, ping 10.1.2.200. Yes, I can. So if I go to PCC, that's a PCC. Here, ping the router 4 address. So 10.1.24.4. 10 ping 10.1.24.4, and I got a reply. Cool. The next thing what I'm going to do is I'm going to put this address, just remove the old one, and just so I can check that I can ping PCA as well. Right? So I'll go to router 4. I'll up arrow, Control A to go in front, and no, I want to remove the old command and I want to paste the new command. Now I'm just going to make sure that I can ping PCA. So end ping 10.1.3.200. I think that's the IP address of PCA. Yep. Okay. And yes, I can. So if I go to PCA, make sure that I can ping the ping 10.1.34.4, and yes, I can. Okay, cool. What we want to do now is we want to configure IPSLA. I'll remove that command and then we start again from the beginning. First, we want this to be our primary link, as long as I can ping this DNS server or PCC. That second I can't ping the PCC, or that as soon as I can't ping PCC, then I will switch this as that will be my primary path. Okay, that's the idea. So to configure that, we got rid of this. We start with IP SLA, and then we give it a number. So for example, if I go to config T IP SLA and I hit the question mark here, for example, right at the top is entry number. We can give any number IP SLA. So say IP SLA 11. Doesn't matter. You can pick one or whatever you want. So IP SLA. Now you see that you're going in the IP SLA configuration mode. So if I hit the question mark here, I can see what I can do. I can use the ICMP echo message, the jitter. I can use the DHCP operations. So kind of this is all for reliability. So in the basic CCNA curriculum, we only need to know how to do ICMP echo operation. So we want to say, okay, ICMP echo and then the IP address. So we say as long as we can ping the 10.1.2.200, 10.1.2.200. Now we can say, if I had the question mark, what can we do here? So we can say for frequency, for example. So how many seconds we want to set? Frequency in seconds. So say we want to ping that IP address that host every 5 seconds. Now your ISP doesn't need to know that you're actually doing this. You are pinging something deep inside the network, making sure that the network is performing properly. Okay, that's all there is to configure IP SLA. Now we need to actually enable this SLA when it's going to be running. So we can choose like time, for example 9 to 5 or say 10 to 11, just when it's busy period or something. But for us, we're just going to make sure that we schedule the SLA 11 to run live, to run forever. We're going to ping it forever. Okay, so you can ping it for a day, for a week, or for a month. And we want to start this now. So we can ping it forever, and we started the ping now. So let me write this in the notepad, these commands, what we did. So IP SLA 11, we said ICMP echo 10.1.2.200, and then we said frequency, we said 5. We type exit, and we enable the IP SLA. IP SLA schedule 11 live forever, start time now. Okay, so two steps we did there. We enabled the IP SLA. We just told what IP address and what we want to do. We want to ping it. How many seconds? Every 5 seconds. And we enabled it when it's going to run. Well, we running it forever, and we started right away. Now, this, we need to enable it for tracking. So we're going to track this SLA. For as long as we can ping, the tracking is good. Well, minute that we can't ping anymore, that's it. So we create the track 1, for example, IP SLA 11, and reachability. We are tracking reachability. So if I copy this and I put it on my router, so track 1 IP SLA 11. So this track 1 will be active when this, as long as we can ping it, the destination. And then we create a static route. For example, so we say IP route, all zeros, any network with any mask. We are going to 10.1, 10.1.24.2 to this destination for as long as track 1 is active, it's on. Cool. Then we can enable as a backup, so floating static route, we can create a IP route, any network, so 4 zeros, with any mask. We will go to 10.1.34.3, and we increase the administrative distance, say to 200. Okay, so if I do show IP route, at the moment there's nothing, there's no routing table here. Oh, the only old static route. Let me remove that. So if I do show run, oops, so show run. Yep, this one. We just want to remove the config t, no, and say this. Okay, if we can do show IP SLA statistics already, there's already oh, we can't even ping it because we haven't got any routing table. So if I say show IP route, we can say, because we don't know. Oh, I thought I removed that. Oh, I did enable it, not remove the config t. Just repeat, Control A to go in front, no, end. Show IP route. Show IP route, there's nothing. I only know what is directly connected and the local interfaces. So if I say show IP SLA statistic, then I can see that, well, I'm getting all failures because this router doesn't know how to do the routing. So this is our routing. Copy, go to the global config, and then paste it. Enter. End. So now the track 1 is going to be active, and we should be able to route to ping that destination, the PCC. So if I say show IP route, now we can see that on the routing table it's default static route. We have 10.1.24.2. So we are using router 2 as a default gateway. Now if I ping, for example, ping 10.1.2.200, now you can see that it's fine. If I stop, for example, PCC, I disable its network card, then we're going to switch to the backup link. From the primary link, we're going to go to the backup link. So if I go to PCC, this is my PCC, go to the network card, and in here, I disable this. Go back to the PC, to router 4. You'll see the tracking very soon is going to come saying, okay, the tracking down, and the routing table will change. So show IP route, we already changed. As soon as you find out right away that actually this interface has gone down, the network has changed to go into this path, to 10.1.34.3. If we, for example, if I enable that interface card, then it's going to go back to the G0 towards G01. So if I go to router PCC, and just enable this, go back to router router 4, show IP route, see the tracking is up, and now the route has changed. So that message there, the IP SLA 11 reachability down to up, and that's now I'm using the primary path, which is 10.1.24.2. okay, so if I again, we can try it again. As soon as I disable it, the router can't ping it anymore. Show IP route. Nope, still. See, now the reachability is down, and we switch towards our backup path. If I enable the route, that interface card, now I can ping it. So I should switch. So I'm keep doing this until I see it. Look, now before I even put the next one up, it's gone towards our primary path. Okay, just to let you know, there is a configuration, there is a link here between router 3 and router 2, which I put it on like this. So I stopped the video, and because I see the trackability, when I was switching this interface up, it wasn't coming back. So I put this link in as well, just to make sure that it's coming back up. Okay, so the commands I did behind the scenes while I stopped the video was in router 3 or 3, I said I put an interface connected to that network of R3, interface G02, and said IP address 10.1.2.3 255.255.0, no shutdown. Then, because what happened is the packet before it was like this, so it was working here. When I shut down this interface, then it switched over here. But when I put this interface back up, it was still just going there. It's like it wasn't reaching it. So what I had to do, I said, okay, well, router 3 has to know that it has to go and be able to ping that interface. So then I connected this. As soon as router 4 could ping that interface, the backup, they started going this way towards our primary link. Okay, so this is very cool, very, very interesting. So show IP route, we can see we're using the primary link, but it's not show IP SLA statistic. For example, we can see that we have success 46 and we have some failures, and SLA is 11. So if I say, for example, I go back to router PCC and I disable that, go here, show IP route, it's going to switch towards the backup. Let's see it. There we go. It switched to the backup because the reachability has gone down. So now we are using the administrative distance of 200. Switch the network card on, go to the router, show IP route. As soon as it can ping, that's it, backup. Not yet, 200. There is, reachability has gone up from down to up, and we're using our primary path with administrative distance of 1. I hope this is informative for you and you'll be able to configure this on yourself. Thank you very much for watching. Please have a look at my other videos and don't forget to subscribe. This has been Astrid Krasniqi. Bye bye.